Hello. Let's go ahead and take a look at the solutions to quiz 5. So let's call this our key here. So problem 1, solve and write the solution set in interval notation. Remember, when you're solving a nonlinear inequality, the first thing you wanted to do was make sure that that was set equal to 0. So let's get started by subtracting 4 from both whole sides so that we now have 0 on the right. Now we want to go through that 3-step process. Step 1 was to find the zeros. Now we're going to take the inequality and turn it into an equation. Now that it's an equation, it's okay to run through and clear fractions, multiplying everything by x minus 2. We clear the first fraction, 3x plus 1. Now we're going to do negative 4 times x minus 2 to get a negative 4x, and a negative 4 times a negative 2 is a positive 8. Combining like terms, 3x minus 4x, negative x, 1 plus 8 is 9. Subtract 9, and then divide by negative 1 to find that x is 9. Second step, we're just going to find our bad numbers. Remember, bad numbers were numbers that were not in the domain. This is a lot easier. In fact, we just want to look at the denominator, and we can see that the denominator would be 0 when x is 2. So you don't really need to show any work there. Now we want to take those zeros and bad numbers and place them on the number line, and we're choosing one number now from each interval. And remember, we're not plugging it in to the original, we're plugging it into the equation that we've set equal to 0 to check for positivity or negativity. Over here, the easiest number to pick wouldn't be 1, it would actually be 0. Plugging in 0 on top, I get out 1. On bottom, I get out negative 2. So that's a negative 1/2 minus 4, negative 4 1/2. That interval is negative. Easiest number in this interval would probably be 3. When I plug in 3 on top, 3 times 3 plus 1 is 10. On bottom, I just get 1. So 10 divided by 1 is 10, and 10 minus 4 yields 6, positive 6. Over here to the right of 9, I would plug in 10. So plugging in 10, on top, I get out 31. On bottom, I get out 8. On my calculator, 31 divided by 8 yields 3.875. And when I subtract 4, I get a negative 0.125, placing me in negative territory, like this. Remember, the goal was to find when we were greater than or equal to 0. So greater than 0 means we want to take the positive intervals, shading here. 2 was my bad number. We'd never include a bad number, so soft bracket there. 9 was my 0. Sometimes we include zeros, sometimes we don't. Look here. We wanted to know when this was greater than or equal to 0. So because of the equal to, we're including the 0 hard bracket on the 9. So my answer in interval notation would be the interval 2, 9, not including the 2, but including the 9. Problem 2 was a variation problem. First thing we want to do is translate the English to algebra. The area of a projected picture on a movie screen varies directly as the square of the distance from the projector to the screen. So area A is equal to K, our variation constant. So all our variation problems always have a K value in them. And then because it was direct variation, we do not need a fraction here. We want it varying directly, though, as the square of the distance. So not just D, but D squared. Continuing to read, if a distance of 20 feet produces a picture with an area of 64 square feet. So stop there. Distance is 20, so replace D with 20. A, the area, is 64. Replace A with 64. And remember, they'll give you everything except for K. Now we're going to run through and solve for K. 20 squared is 400, so I have 64 equals 400k. And on my calculator, dividing 64 by 400, you find that k then is 0.16. To finish, I'm just picking up after the comma. What distance produces a picture with an area of 100 square feet? So this time, area gets replaced with 100, k is 0.16, and d is what we're looking for, like this. Solving for d, the first thing we need to do is divide by 0.16. So 100 divided by 0.16 yields 625. On the other side of the equation, we still have d squared. To get d alone, take the square root, and you'll find d is plus or minus 25. Obviously, distance can't be negative, so we're going to keep the positive and label that feet. Next problem, graphing an inverse. Remember, the reflection line for an inverse function was the line y equals x. So if we look at that as y equals mx plus b, m, the slope would be 1, b, the y-intercept, would be 0. So y-intercept of 0, right in the middle. A slope of 1, or 1 over 1, tells me to rise 1, run 1. So we'll go up 1, right 1, up 1, right 1, up 1, right 1. We can also reverse both of those, going down 1, left 1, as follows. Sketching in that line looks like this. Remember, we can also interchange x and y in any known points. This point here right now is the point 1, 2. If we swap x and y, it becomes the point 2, 1 right there. Similarly, down here, that's the point -1, -3, which would become -3, -1. Also, any points on the reflection line would stay exactly the same, like this. Now, using those points along with the reflection line, we can now sketch the inverse function, which would look like this. So if the original function was f, that new function that we just graphed would be named f inverse. Last question, is the inverse relation a function, why or why not? Well, if we look at that new black line that we just put in, sure enough, it passes the vertical line test, which is the test that we use to determine if a graph was the graph of a function. So yes, and the reasoning would be that it passes the vertical line test. All right, let's flip things over to the back here. Problem number 4 is now asking us to find an inverse algebraically. Remember, our first step was to set f of x equal to y. And now that we have an x and a y, we can go ahead and interchange x and y in that problem. Now our goal is to solve for y. So first step, clear the fraction, multiplying both sides by y plus 3. On the left, when I distribute the x, I would get xy plus 3x. On the other side, I would clear the fraction and just get 2y minus 1. Now, if we're solving for y, we're going to get everything with a y in it to the left. So I'm going to subtract that 2y over to the left. Everything else will be on the right. Keep the -1 there and then subtract 3x as well. And then remember the trick to make it appear as if there was only one y in the problem was now to factor out a y on that left-hand side. So if we pull out a y, we'd have x minus 2 remaining. And the problem now looks like this. Finally, to get y alone, divide both whole sides there by x minus 2. And we can now see that f inverse of x is equal to -1 minus 3x all over x minus 2. Answer looks like this. All right, problem 5. Distance, rate, and time problem. Remember, anytime we're doing distance, rate, and time, the easiest way to come up with those equations was to make a table with distance, rate, and time across the top. When you read through this problem, you'll find the two categories were flying with the wind and against the wind. Very specifically, the problem asks us to find the rate of the plane in calm air and find the rate of the wind. So let x be equal to the rate of the plane, and let y be equal to the rate of the wind. Probably the easiest column to fill in is the time. A plane flew 800 miles in 4 hours with the wind. The plane traveled the same distance in 5 hours against the wind. Remember that when you're flying with the wind helps you to, or helps the plane rather, to fly faster than it can by itself. So by itself, the plane goes X miles per hour. The wind is pushing it along faster than it can actually go. So with the wind, the plane is flying X plus Y. Similarly, when the plane fights the wind against the wind, it would be slower. Rate then would now be X minus Y. The distance column, we aren't going to use the 800 miles. Instead, we're going to use the relationship between distance, rate, and time. Remember that the relationship between distance, rate, and time was that distance was equal to rate times time. So to fill in this column, we're going to multiply the rate and the time together. So if we multiply x plus y times 4, the distance here would be 4x plus 4y. Similarly, against the wind, x minus y times 5, 5x minus 5y. Finally, we want to use the fact that that distance was actually 800 miles. So our first equation would be 4x plus 4y is equal to 800, whereas our second equation would now be 5x minus 5y is equal to 800, as the distances were the same. This equation is best suited for the elimination method, and I'm going to choose to eliminate the y's as one is already positive and the other is already negative. Multiplying the top by 5 to get a positive 20y, I would then multiply the bottom by 4 to yield a negative 20y. Top equation becomes 20x plus 20y is equal to 4,000. Bottom equation, 20x minus 20y is equal to 3,200. Now that we have an elimination, we'll add the equations together. The y's eliminate, and we're left with 40x equals 7,200. Dividing both whole sides by 40 here, 7,200 divided by 40 on my calculator yields 180. At this point, we now know that the plane flies 180 miles per hour. To finish, we still need to find the rate of the wind. So we're going to take that 180 and plug it into either of the original equations. I'll just grab the first. 4 times 180 plus 4y is equal to 800. 4 times 180 yields 720, plus 4y is 800. Subtracting 720, 4y would be equal to 80. And finally, dividing by 4, we find that y is 20. So the wind is now 20 miles per hour. At this point, you are finished with the quiz. If you're interested in the solution to the extra credit, f of 0, well, notice if we're sitting at 0 and we follow that down to the point 0 comma negative 4, that point means when you plug in 0, negative 4 comes out. So f of 0 would yield negative 4. So 3 times negative 4. To find f inverse of negative 1, because x and y swap, we, instead of going to x equals negative 1, want to travel out to y equals negative 1. Y equals negative 1 is here, and if I follow that over, I get the point x first, then y, negative 3 comma negative 1. But if we interchanged x and y, that would yield the point negative 1 comma negative 3. So f inverse of negative 1 would give negative 3. 3 times negative 4 is negative 12. Negative 12 plus negative 3 gives negative 15.